Hello everyone. In a previous lecture, we will discuss about the EMF equation of the DC machine, classification of the DC machine like separately excited, self-excited, and the further classified the machine like series, shunt, and compound. In this lecture, this is the fourth lecture for electrical machine 2. So in this lecture, we will study about the basic performance of the DC generator, characteristics of the separately excited DC generator, characteristics of the DC shunt generator, characteristics of DC series generator, as well as the characteristics of the DC compound generator, and the reference of this presentation. So this is the outline for the presentation. We will move this topic in step-by-step manner. So the topic 1 is basic performance of the DC generator. Performance curve of the DC generator is that curve which show the ability of delivering output voltage of a DC generator with the change in load current from no load to full load. These are also called as characteristics curve. From the performance curve, we can get a clear idea about the voltage regulations of the various kind of generators. The lower the voltage regulation will be, the performance of the generator will be better. Generally, following three characteristics of the DC generator are taken into consideration. Number one is open circuit characteristics, in short OCC. Second is internal or total characteristics, and number third is external characteristics. तो ये तीन बहुत ही important characteristics हैं जो हम consider करते हैं. These characteristics of the DC generator are explained one by one. So first, the open circuit characteristics or OCC, or we can say that it is plotted between the E0 and IF, means field current. Open circuit characteristics is also known as the magnetic characteristics or no load saturation characteristics. ये characteristics हमें कब मिलती है? On no load condition पे. These characteristics show the relation between the generated EMF at no load, denoted by E0, and the field current IF at a given fixed speed. The open circuit characteristics curve is just the magnetization curve, and it is practically similar for all kind of the generator. The data of OCC curve is obtained by operating the generator at no load and keeping a constant speed. Field current is gradually increased and the corresponding terminal voltage is recorded. The connection arrangement to obtain the OCC curve is shown. This is the diagram for OCC characteristics. For shunt or series excited generator, the field winding is disconnected from the machine and connected across an external supply. So in this diagram, the field winding is connected to the DC supply and one ammeter connected series with the field winding. An armature winding is open circuited, or one voltmeter is connected to measure the open circuit voltage. Because the open circuit, the voltage is maximum and current is zero, so we can measure the voltage. Now from the EMF equation of the DC generator, we know that Eg is equal to K phi, or Eg is equal to phi Zn upon 16 to A. Hence the generated EMF should be directly proportional to the field flux, or we can say that, and hence also directly proportional to the field current. However, even when the field current is 0, some amount of the EMF is generated. This initially induced EMF is due to the fact that there exists some residual magnetism in the field pole. Due to the residual magnetism, a small initial EMF is induced in the armature. This initially induced EMF adds the existing residual flux and hence increasing the overall field flux. This consequently increases the induced EMF. The open circuit characteristics follow a straight line. However, as the flux density increases, the poles get saturated and the phi become practically constant. Thus even V increase. If further phi remain constant and hence Eg also remain constant. Hence the open circuit curve look like the VH characteristics or VH curve. You can see the diagram. In a horizontal axis, we consider a field current represented by IF, and a vertical axis we consider A0 or no load voltage. The above figure show a typical no load saturation curve or open circuit characteristics for all type of the generator. Now number 2, internal or total characteristics. It is plot between the E to IA, means armature current. An internal characteristics curve show the relation between the no load generated EMF called EG and the armature current IA. So we can say that it is a relationship between the EG and IA. The no load generated EMF EG is always less than 2 E0 due to the armature reaction. EG can be determined by subtracting the drop due to the demagnetizing effect of the armature reaction from no load voltage, means E0. Therefore, internal characteristics curve lie below the OC. Now number 3 is external characteristics. These characteristics plot between the V and IL. The external characteristics curve show the relation between the terminal voltage V and the load current IL. Terminal voltage V is less than the generated EMF EG due to voltage drop in the armature circuit. Therefore, external characteristics curves lie below the internal characteristics curve. External characteristics are very important to determine suitability of a generator for a given purpose. Therefore, this type of the characteristics is sometimes also called as performance characteristics or load characteristics of the generator. Internal and external characteristics curve are shown below for each type. Now the next topic is the characteristics of separately excited DC generator. So what is separately excited DC generator? In this generator, we can provide the excitation separately to the generator, so called the separately excited. So the characteristics is plot between the load current and the terminal voltage or generated voltage or no load voltage. If there is a no armature reaction and the armature voltage drop, the voltage will remain constant for any load current. Thus the straight line AB in the above figure represent the no load voltage versus load current. तो जो पहली लाइन है हमारा AB ब्लू कलर से जो दिख रहा है वो रिप्रेजेंट कर रहा है नो लोड वोल्टेज वर्सेस लोड करंट. Due to the demagnetizing effect, the armature reaction, the no load generated EMF less than to the no load voltage. The curve AC represent the no load generated EMF EG versus load current IA. That is internal characteristics, as IA is equal to IL for a separately excited DC generator. Also, the terminal voltage is lesser due to ohmic drop occurring in the armature and brushes. The curve AD represents the terminal voltage versus load current, that is external. Now we will move the next topic, the characteristics of the DC shunt generator. To determine the internal and external load characteristics of a DC shunt generator, the machine is allowed to build up its voltage before applying any external load. To build up voltage of a shunt generator, the generator is driven at the rated speed by a prime mover. Initial voltage is induced due to residual magnetism in the field pole. The generator builds up its voltage as explained by the open circuit characteristics or curve. When the generator has built up the voltage, it is gradually loaded with a resistive load and readings are taken at suitable interval. The connection arrangement is shown. So this is the connection arrangement for DC shunt generator. In a DC shunt generator, the field winding is connected parallel with the armature winding. You can see the diagram. So field current we can represent it by IF, and armature current we can represent it by IA, and IL is called the load current. Unlike separately excited DC generator, here IL does not equal to IA. For a shunt generator, IA is equal to IL plus IF. Hence, the internal characteristics can be easily transmitted to EG versus IL by subtracting the correct value of IF from IA. So, the characteristics of DC shunt generator. The first curve AB is denoted the characteristics between the no load voltage and load current. The characteristics AC is represented the characteristics between the generated voltage AC and load current IL. And the third, the AC characteristics is called the internal characteristics, and AD is called the external characteristics, which is plot between the terminal voltage and the load current. So in this diagram, these three characteristics are showing. Number one is called open circuit characteristics, second is called internal characteristics, and third one is called the external characteristics. During a normal running condition, when load resistance is decreased, the load current is increased. But as we go on decreasing the load resistance, terminal voltage also falls. So the load resistance can be decreased up to a certain limit, after which the terminal voltage drastically decreases due to excessive armature reaction at very high armature current and increased I²R losses. Hence, beyond this limit, any further decreases in load resistance result in decreasing load current. Consequently, the external characteristics curve turn back as shown by the dotted line in the above figure. Now the next topic is the characteristics of DC series generator. The curve AB in the figures identical to open circuit characteristics. AB जो है वो open circuit characteristics curve को represent कर रहा है. This is because in a DC series generator, the field winding is connected series with the armature winding and load. So the first characteristics AB plotted between the no load voltage and load current. It is also called the open circuit characteristics. And second characteristics means OC is plot between the generated voltage and load current. It is called the internal characteristics of the DC series generator, and OD is called the external characteristics of DC series generator. Hence, here the load current is similar to the field current, that is IL is equal to IF. The curve open circuit, the curve OC and OD represent internal as well as external characteristics respectively. In a DC series generator, terminal voltage increase with the load current. This is because as the load current increases, then the field current also increases. However, beyond a certain limit, terminal voltage start decreasing with increasing in load. This is due to excessive demagnetization effect of the. The next topic is the characteristics of DC compound generator. So this is the characteristics for DC compound generator, or we can say that the external characteristics of the DC compound generator. The characteristics curve AB is known as over compound, AC is known as flat compound, and the green dotted line represented the no load voltage, and blue line means AD represent the under compound. These characteristics plot between the terminal voltage V and the load current IR. The above figures show the external characteristics of DC compound generator. If the series winding ampere turns are adjusted so that increase in load current cause increase in the terminal voltage, then the generator is called to be over compound. The external characteristics for over compound generator is shown by the curve AB in a figure. In series winding, ampere turns are adjusted so that the terminal voltage remain constant. Even the load current is increased. Then the generator is called to be a flat compound. The external characteristics for a flat compound generator is shown by the curve AC. If the series winding has lesser number of the turns, then that would be required to be a flat compound. Then the generator is called to be under compounded. The external characteristics for an under compounded generator are shown by the curve AD. So the DC compound generator, the external characteristics is divided into three characteristics: over compound, flat compound, or under compound. The next is a references of this presentation. So these are the reference. The book's name is Electrical Technology by B.L. Chourasia, and some online sites like Electrical for You and electricaleasy.com. So this is all about the performance characteristics of the DC generator. Any confusion, any doubt, so please ask me. And thank you for watching this video.